Okay, so like I said, last class we dealt with multiplying and dividing. We did adding and subtracting. This class we're going to expand on it, and we're going to be multiplying and dividing. So, with that being said, you should have 3 sheets of paper. 2 full size that says 1, 2, and 3 on one, 4, 5, and 6 on the second one, and then a half sheet of the square roots. Yes. Okay. So we're going to be talking about our game plan. What is our upcoming announcements? Okay. Think about it. Y'all should have been already worked on. What is our objective in multiplying and dividing rational expressions? From that, you have a learn about it, and you also have a Kahoot, which is also in the system. Remember, the Kahoot will be open up until probably about December 14th for y'all to get it in. It is for a grade. So, today, 12-2, multiplying and dividing rational expression. Now, remember these important dates, okay? From here till December 20th, you have your winter break. You have up until the 20th, that's your half day. You have a half day that day. Okay, Christmas break starts on the 23rd. You do not come back to school until January 2nd. So please do not be that student that want to forget that you're on Christmas break, jump up and run to school, and then you realize there's nobody here. The next day you will have off after Christmas break is July 20th. And then, remember, on the 24th is the end of the second quarter. Okay? We will have plenty of stuff done by then, so make sure that you are staying on top of your grade. If you do not have access to a computer or something, let me know. I do have paper copies of the test.
Oh, we got tests coming up in at the Christmas break?
No, just show what you know, your exit tickets.
Okay.
So, right here, what is our objective? I can multiply and divide rational expression, applying properties and exponents when necessary to simplify the radical expression. Oh, okay. I know a lot of y'all saying to yourself, Miss Debbie, that's a lot. Yeah, it is a lot, but it's actually really simple. Okay? We're going to come back to that game. So, what you need to do is, looking at your sheet, looking at problem number 1, following along. It's telling me, what is the square root of 6, the radical 6, parentheses, 3 plus radical 2. So the first thing I want to do is I'm going to rewrite it to where I'm going to take that 6 and I'm going to distribute it inside the parentheses. So now, this is where y'all should be writing down. I'm going to distribute that 6 radical to multiply to the 3, and then the 6 radical to multiply to the 2 radical 2. Once I go ahead, I'm going to break it down into 2 parts. Everything on one side of the plus sign is one part of the equation. Everything on the second side is the second part. We're going to break it down so that we can then solve for it. So I see that I go ahead, 3 times radical 6, I get 3 radical 6. On the other side, if you notice, I have 2 radicals. So I'm going to put the 6 and 2 under the same radical and multiply it. So that line should be extended out. So sorry about that. If you look here, extend your radical line till it's all the way out, covering the 6 and the 2, to let you know that it's both under the same thing. So, but now I can go ahead, what, I see that I have 6 times 2. 6 times 2 is what? 12. So I go ahead and solve that. I got 3 radical 6 plus radical 12. Could I, looking at your chart, could I break down the 6 or the 12 with a perfect number, like a perfect square root, a number times a number that will go perfectly into it? That's 6. What times what?
3.
No, 3 times 3 is 9. What is 2 times 2?
6. Wait, what?
Say it again?
4.
But now 4 times 3 is what?
12.
12. So I can go ahead and break it down. That means I got a perfect square root. In order to come outside the radical, I gotta take the 2 same numbers and I can pair them up and bring them outside the radical, right? Right? So if I break down 4 squared, it'll be what? What times what will give me 4?
2 times 2.
2 times 2. So I go ahead and I'm going to split them up. And then I'm going to go ahead and I take that 4, which is a perfect square number. I put that 2 out in front. Now, going back to what we talked about when we were talking about adding and subtracting. Now, we did the multiplication of the FOIL, or the box method, well, FOIL, first, inner, outer, last. Could I add 3 radical 6 plus 2 radical 3? Could I add those? Remember how we always said like a fraction, they have to have the same what? The common, not numerator, denominator. So our radical, we're thinking of it as like our fraction. That's our down. So could I add 3 radical 6 plus 2 radical 3? Is my radicals the same?
Yeah, my point is just 5 over this.
You can't add them. Your answer is 3 radical 6.
Oh, do you
3 radical 6 plus 2 radicals 3. Because they don't, the 6 and 3 are not common. You can't add 2 uncommon radicals together.
So, what we got 2 from? Is it
You got your 2, remember, looking at your half sheet, what is 2 times 2?
like, oh, this sheet right here, 2
Yes?
times 2.
What is 2 times 2?
It's 4.
So
2 squared.
I'm looking at 2 times 2. If I got 2 of them that can hang out together and go outside and play outside the radical, could I make that happen?
So it's making it into like a 2 square.
Yep, we're bringing it outside.
And wait, so what happens to the square part?
The square part,
Yeah. Stays.
it's gonna, what, a perfect number, and we're gonna put it outside the radical.
So it's just like disappear.
Yes, so if it's 9 times 9, if it says 81, it's 9 times 9. I can just take them as a pair. For every 2 numbers that are identical, they can come outside and play. They come outside the radical. That's how you got 2. Okay, so you'll understand because we got 2 more problems that we're going to work through. So just keep on following along. You got questions? Please answer them. Okay, I'd rather answer your question now than when y'all get too knee deep into the situation and can't come back. Okay?
The math is not a good one.
So, I know. So, back to this. Now, is every answer always going to be like that? No, not at all. Sometimes you'll have the same common radical and you'll be able to add it all the way down. So right here, we're going to multiply. We see that we have 2 plus 4 radical 3 plus 3 plus radical 5. So now we're going to have to expand this, okay? It looks like it's a nuclear code for some unlimited PlayStation, okay? PlayStation games or like an Oculus game.
So like a code.
This is how coding is?
Yeah, no.
Coding is more Miss Stevenson would know about that, more about coding than I do. I thought that was your master's, was that?
No, coding?
Yeah.
What sucks?
That's what IT work, right?
You said IT?
Yeah.
I do not know anything about IT. My degree is in psychology.
Studying of my wrong mind. You see, we wrote it out to where it's elongated, okay? It is a lot because you gotta do your 2 go times the 3, the 2 then times the 5 radical 3, and then you still gotta do your 4 radical 3 times 3, and then you see the big moolah. The big moolah. The big moolah. This is what, this is not simplified. Okay? Now we can go ahead and start working, multiplying and simplifying it so that we can shrink it down. Once we start to do that, we say 2 times 3 is, what is 2 times 3? Yes. Now, with 2 times 5 radical 3, am I going to multiply just the 2 and the 5, or the 2 and the 5 and the 2 and the 3? Remember, one of them is under a radical, so I can't do what? I won't be able to multiply it, right? So, once I look at that, what is 2 times 5? What is 2 times 5?
2 times 5?
10.
10. Obviously, we can't multiply the 2 into the radical, so we're going to keep the radical 3. We look at the next part. We see that we have 4 radical 3 times 3. So the 3 in the parentheses by itself is going to multiply to what outside the radical? What's outside the radical? 3 times what? Right here. I'm multiplying the 3 into what? 3 into what? What is my dot on? 3 times what give me 12?
3 times 4.
Yes. We keep our radical 3, right? Now, looking at the final one, we see that we got on the outside a 4 times 5 is what? Four times 5. If you got 4 nickels, how much money do you have? 20. Now, do I have a common radical? I got 2 radicals on here, but we're multiplying. So we're looking at what? 3 times 3. Okay, there's 2 radicals. So what is 3 times 3? What is it? 9. Look at your sheet. Look at your little half sheet. Is 9 a perfect square?
Yes.
1 times what will give me 9?
3 times 3.
3 times 3. So, if I got a perfect number under the radical, and I know that such and such times something, which are the same numbers, can they go outside and play with the 20?
No.
I can break down the 9?
Yeah.
I can break down that 9. I can go ahead and, when I square it, I bring that 9, that 3 outside. So now I have 6 plus 10 radical 3 plus 12 radical 3 plus 20 times 3.
Wait, am I supposed to wipe all that down?
Yes. But we're not done yet, because now we can do what? We can simplify. We can leave it like this, but then it looks like a hot plate of mess. Okay? It looks like some of y'all brains after Thanksgiving, like what I'm looking at right now. Yes. Okay. So now, when we always want to simplify, we want to start with whatever we got to multiply or divide, then add and subtract. What is 20 times 3? 20 times 3. Say 23 times. 20. What is 2 times 3?
6.
And then you put a 0 on behind it? I mean, 60. Okay? That's a plain coefficient. If I see this right here, I have a plain coefficient. I also have one over here. If I can get around Javon's head. My light. Okay? So now I got 60 plus 6. What is that? 60 plus 6.
56.
66. Now, do I have a common radical?
No.
I don't have a common radical? 10 radical 3 plus 12 radical 3? I don't have a common?
I guess you do.
So that means I can add the numbers on the outside. Remember how last class we were adding? As long as they have a common radical. So, what is 10 plus 12?
22.
Do I add the radical or do I just keep it the same? Remember, we're adding. So you gotta have that base. Come on, nothing's gonna stop us now. We got this. This world is not ready for us.
1 point is 5. So, these two got 1 point on it.
Oh my. That's
So, as Andrew said, 10 plus 12 is 22, but we do not have to add the radicals because they are common when we're adding. It's different when multiplying, it's different when they're adding. And when they're adding, they have to be the same. Now, I know some of y'all are like, Mr. Denny, that really destroyed my brain. I know. That's why we're good at it. We're gonna have y'all so good at the end of the school year, y'all will be able to come back here and teach this for me. While I'm out for another surgery.
You got another surgery?
So wait, how do all these told you when they were like, okay?
Yeah,
Was it lunch?
it's okay. I should have taken it easy over Thanksgiving break, but I didn't. But that's what it is and what it's done. Now, we got one more multiplication before we gonna go back into our Kahoot. So, see I got 6 plus radical 3 times, it's supposed to be, that plus sign is not really supposed to be there, 6 minus radical 3. I'm going to go ahead and I'm going to distribute it all out. You see how I write it out long. Look how long it comes out to be. 6 times 6 plus 6 times negative radical 3 plus radical 3 times 6 plus radical 3 negative radical 3. What does that mean? That means we can just go ahead and shrink it down. Now we're going to end up with 36 minus 6 radical 3 plus 6 radical 3 minus radical 3 radical 3. What is 3 squared? 3 times 3. 9. So, with that being said, I see that I'm going to have to rewrite it to where it's now 3 times 3 under the radical. We know it's 9. Once we get 2 of them together, then 9 is a perfect what?
Square.
Perfect square. I can go ahead and break this down, break the 9 down, and put the 3 outside the what? Outside the what symbol?
The square.
Square root, the radical, okay? Now, I see I got 36 minus 6 radical 3 plus 6 radical 3 minus 3. What do you see about the radical? One is what type of operation and the other is the opposite.
Minus.
Say that again?
Minus.
One is a minus and the other one's a... One is a minus and what's the other one?
Positive.
Positive.
Positive. They're the same thing. If I say I got 1 minus 1, or say 1, positive 1 minus negative 1, I'm going to do what? Get what? I'm going to get what?
1.
No! They cancel each other out. What is 6 radical 3 minus 6 radical 3?
Zeroes out.
It zeroes out, right? Yes. So that means I can go ahead and put an X between those two in the middle, and it leaves me with 36 minus 3, which is, there you go. Okay. Go into your device. If you go into our December 2nd folder,